Boosting engine efficiency. Internal combustion challenges. Imagine a machine that turns fuel into motion, powering cars, trucks, and even some planes. That's what internal combustion engines do, but they face many hurdles in becoming more efficient. These engines convert the chemical energy stored in fuel into mechanical work through a series of controlled explosions inside cylinders. But a lot of that energy is lost as heat, friction, or incomplete burning of fuel, which limits how well they perform. The efficiency of these engines depends on the thermodynamic cycle they follow. Gasoline engines usually use the Otto cycle, which involves compressing the fuel-air mixture, igniting it, and then expanding gases to push the piston down. Diesel engines follow the diesel cycle, where air is compressed first, then fuel is injected and ignited by the heat of compression. A key factor here is the compression ratio, which is how much the piston compresses the fuel mixture. Higher compression ratios generally mean better efficiency because they allow the engine to extract more energy from each explosion. However, increasing compression ratio isn't always easy. Gasoline engines need high-octane fuel to prevent knocking, which is when the fuel ignites too early and causes knocking sounds. Diesel engines can handle higher compression ratios because they ignite fuel through compression alone, without a spark. But pushing the compression too high can cause engine parts to wear out faster or even break. Friction inside the engine and the effort needed to pump air and fuel in and out also eat up a lot of energy. In typical driving, only about 20 to 35% of the fuel's energy actually turns into useful work. The rest is lost as heat, friction, or used to overcome resistance. That's why reducing mechanical friction is a big focus. Engineers are designing parts like longer connecting rods to lessen side thrust on the cylinder walls, which helps reduce wear and heat loss. Improving how the fuel burns inside the engine is another challenge. Running engines with more air than fuel, called lean mixtures, can cut down on fuel use and emissions. But if the mixture is too lean, the engine might misfire or stall. To fix this, manufacturers use advanced fuel injection systems, better piston designs, and turbochargers. These help mix fuel and air more evenly, leading to cleaner, more complete combustion. Recent innovations include coating engine parts with special materials to reduce friction and designing multi-hole fuel injectors that spray fuel more uniformly. These changes help keep the engine cooler, reduce oil breakdown, and improve overall efficiency. Making engines lighter and more aerodynamic also helps because it takes less energy to move the vehicle. In the end, boosting internal combustion engine efficiency is about balancing the principles of thermodynamics with smart mechanical design. It involves squeezing more work out of each fuel charge while reducing losses from heat and friction. As we look toward greener fuels and cleaner emissions, these improvements will help engines run better and cleaner, making a real difference for the environment and our wallets.